We're going to have a look at making a little programming language. So we're going to try and make a full little programming language, if that makes sense. And I'm going to try and thread a needle here, because if I make the language too small, it'll look like gobbledygook and no one can tell what I'm doing. And if I make it too big, well, we would run out of YouTube's budget for disk space. So I'm going to try and find that sort of little bit in between. And what I'm going to try and do is build it up bit by bit so that we kind of can see, oh, this makes sense, and then we'll add a bit more. So where are we going to start? Well, I'm going to make what's called an interpreter. So people get very religious about compilers versus interpreters. Call it what you want. It's an interpreter. It doesn't matter too much. And what we'll start by doing is just making a little calculator effectively that can do little integer expressions, and then we're going to build up from there. But before I do that, I make tons of mistakes when I'm programming, so I'm going to start very simple, because otherwise I'll get it wrong. I'll use Python today, Sean. I'm feeling like a Python Dave, don't know why. We're going to make our little programming language. It's going to read in from a file, so I'm just going to check that I can read in from a file correctly in case I've forgotten how to do that. So I'm going to make an evaluation function that's going to be able to take in a string that I've read from a file and give me back a number after it's evaluated things. So I'm just going to be very, very, very simple at first. I'm going to say that I'm going to call the evaluation function. By the way, you know from our time together in front of the judge that I cheat monstrously, so I will not be doing some things that I probably should. There'll be no error checking. You do anything wrong, you get to find out what happens. And I'll probably make some mistakes, very few of which will be deliberate. So let's try this and see where I've gone wrong. So let's save that little file. Maybe I should make that a little bigger. That's probably better. And let's write our first program in our little program language. So I'm just going to write almost a calculator, but mathematical notation as we know it is completely bonkers. You know, when you say 2 plus 3 times 4, you have to remember all these weird rules about what does the plus and the star precedence bind to. We waste our time, and it's actually quite annoying to program. So I'm going to cheat and say we're going to use what's called reverse Polish notation. So instead of saying 2 plus 3, we're going to say 2, 3 plus. So if you're familiar with the idea of a stack machine, this says when you run this expression, you see the integer 2, push it on a stack, see the integer 3, push it on a stack. When you get plus, take the last two things off, add them, put back the answer 5.
Computer scientists, when they looked at reverse Polish notation in the late 40s and early 50s, just thought all their Christmases had come at once.
Good news, I can read in a string from a file. Excellent. So I keep my little program at the top there just so you remember it. Now, a programming language implementation, the first thing it has to do is take in text and parse it. Now, we could do about 9 hours on that. Good news, we're going to cheat. And the way we're going to cheat is the following. There is, Python strings have a function called split. And if I just say s.split, it happens to do exactly what I want. It will split my input on the white space. So it's going to, well, I'll show rather than tell. It split my input up and put my little 2, 3 pluses, put it in a list with 3 items, the integer 2, comma the integer 3, the plus operator. It's just done that naturally, happens to be exactly what I want. So I then said reverse Polish, we need a stack, so we'll make an empty stack. And then we're just going to go over all of these tokens that we split our input up into, the individual elements split by white space, and just put them on the stack, take them off as appropriate. So we'll say for token in the tokens, we'll say if we're looking at a number, it's a number as a string, so it consists all of digits, what we're going to do is push onto the stack the integer value of that token. So that'll push on 2 and 3, for example. Else, and you can see here, if you write an incorrect program, God knows what's going to happen. If you hit the plus operator, and I'm going to do something that will seem weirdly pedantic at first, there might be a reason for it later if we're lucky. We're going to take off the items in what seems like the wrong order. I'm going to pop the elements off the stack. So I'm going to say pop the right-hand side off the stack, and then pop the left-hand side off the stack. And then I'm going to add them together and put the value back on the stack. So I'm going to put left-hand side plus right-hand side on the stack. Okay, and once I've finished, if I've got it right and the program's correct, if we're lucky, the stack will have one element, we can print it out and see the number. This is never going to work first time. Okay, embarrassingly, it works first times. It actually worked. It actually prints out 5. Let's check I'm not completely lying. We'll change the 3 to a 4 if I can do that. So it really prints out 6. Very good. So that's the first little bit. So now what we've got is, we'll call that an expression evaluator. It's a little simple mathematical expression, and it works. A programming language has lots and lots of lines in your file. It doesn't just have one line. So what we'll do now is we'll build it up so we can have multiple mathematical expressions on multiple lines. There's a ton of ways I can do this, so I'll just jump straight in. I'm going to make a class, because that will be a little bit useful for me later, I think. I'm going to call this function here, I think I'll give this a different name. I'll say this is the evaluator of an expression. And I'll now say this is new function I'm writing here called ev. That's going to be my top level evaluator that will take in lots and lots of expressions and do something with them. Now I've got to take my file in, and let's actually make this do something. So we'll now say 4, 5. Let's just keep the plus to keep it simple. So we've now got 2 expressions in input. So I've now got to break my input file up by new lines. And I think this might be a theme of this video. We're going to use the split thing again, which is just this wonderful cheaty function for today's purposes. So what we're going to do is we're going to say split the input by new line characters. So that will hopefully give me 2 new lines. But I want to throw away empty lines because those cause me problems. And I'll just write this out because it's kind of fun. Right, so that gobbledygook there, if I've got it right, says split the thing into new lines and throw away any empty lines. It's using this particular syntax in Python. So I'm not going to explain in too much detail, but hopefully that works. And then I'm going to say for each line in my file, evaluate the expression. And then we'll change the print here into return. Okay, now we can see what I've got wrong. Yes, of course, I haven't done the class there, so fine. ev.ev, right. Yes, I should have added this. Programming is just basically a continual reminder that I can't do anything correctly. And I need to save the file as well. Okay, that has actually worked. We've evaluated both lines in the file. The first line prints out 6, the second line prints out 9. So we can now, we're starting to get something that looks a little bit more like a programming language in the calculator, because we've got multiple things and you can only do one thing at a time in a calculator. So that's nice. Still doesn't feel much like a programming language to me. I don't know about you, Sean, but so I would say probably the most obvious next difference between the two is that a programming language has variables. So I'm going to add variables in. I think that's fun and kind of useful. So I'm going to change my programming language so I can now say things like x is 2, 4 and I'm going to say y is going to be x 5+. So I can define a variable, I can read from variables. If I can get this working, I feel like it will look more like a programming language. Now that means I'm going to have to change more of my little evaluator. So it's starting to get a little bit more complex here. I am, again, going to misuse the split function, and it has a special thing called max split. So if I just say split a line, it'll split everywhere there's white space. But if I say only split the first n entries, it'll split the first ones and then say, I won't split anymore even if they've got white space or whatever in. And that's going to be exactly what I need here. For each line, I'm going to assume each line is a variable equals some arbitrary length expression. So I'm going to say split the line and then split it at most twice. That will give me back 3 things. It will give me the variable name, the equal sign, so I'm going to assign that to the underscore, throw it away, don't care, and the expression. So now, hopefully, if I've got this right, we'll see, and we'll just do a little bit of debugging here to see if I've got it right. So this will splat on the second line in some way. That's fine, but it does print out that x is 6. Good. So now we're going to have to store our variables, and so we can read them later. So I'll just say, fine, I'm going to have a very simple, Python calls this a dictionary, you might call it an associative array.
Instead of having subscripts which go from, let's call it 0 to something, you have arbitrary subscripts.
This data structure that maps names, variable names, to values, and this will be updated as we interpret our program. So we'll say whenever we evaluate x equals 6 or whatever, then we set the variable x, whatever the name is, to the result of the evaluator. And I don't want to do print statements, it's too hard. So what we'll do, at the end of our program, we'll just print out the value of all of the variables at that point, and then hopefully you can work out which one you are most interested in. I won't ask you to pick a favorite yet. So now, that will store the value of a variable, but that will still go splat, because when I hit y equals x 5+, well, it doesn't know what to do with x. So we need to say how to read from a variable. And again, I'm going to make it very, very, very stupidly simple. I'm going to say if you get a token that also is a variable name, then just push onto the stack the value of that variable. So that has now worked. So I've got x equals 2, 4 plus, so that gives me 6. I then add 6, 5 plus, assign it to y, and I get 11. So I'm printing out the right variables there. That's actually worked a little quicker than I thought I might get. So now we've got something that I feel is looking more like a programming language. I could now just keep writing lots more lines in a linear thing, but there's one thing left that I think differentiates this sort of thing, which still feels a bit like a calculator, from a programming language. Here, we start at the top of the file, and we just keep going downwards and execute each line once.
So branching, maybe, is that what we're looking?
Yes, so, yes, branching and loops together, because I think if you only have loops, then it never stops, and if you just have branches, it's not as much fun. But once you get branches and loops, then you've got the flavor of something. It can execute some number of times determined by a later stage, not determined by the text you wrote. Mm-hmm. So you're ahead of me. So that's what we're going to do. We're going to implement loops. And it turns out that is going to be enough to actually allow us to write a vaguely, and I want to say vaguely, interesting function that you might recognize. We will implement in our little programming language, drum roll, the factorial function. Yeah, okay. I told you it was a little. So we'll have to add a couple of extra things in as well. But let's write out what in our little language the factorial function will look like, and then we'll make it work. And you'll notice there's a pattern here. I'm always updating the program I want to run, watching how it breaks, and then fixing my little language implementation. So we're going to say that we're going to ask for the factorial of a value we put in the variable n. So I'll start with factorial 5, and I'll put the result of the factorial in a variable called r. And then I'm going to introduce while loops. And now there's various ways I can express this function. But I can say the while loop keeps going round while n is greater than or equal to 1. Now immediately that means we're going to have to implement comparisons greater than or equal, which means some sort of Boolean thing, so conditionals. And obviously then the while loop's going to have to loop round a bit. So we'll do that in a couple of stages. The body of this particular while loop is the standard factorial effectively. So we'd say r is r times n, and n is equal to n minus 1. Saying that whilst typing in reverse Polish is harder than I expected.
You did well.
Thank you very much. I'm here all day. Okay, so with luck, that's our factorial function. So that's what we've got to get running. So we can see immediately there's quite a few things here that we don't have in our little language implementation. We don't have multiply, minus, greater than or equal, or while. So let's do the easy bits first. So we'll do the binary operators. We'll do minus and star, and then we'll do greater than or equal. These ones all follow basically the same pattern. Star, minus, plus, they'll say get a left-hand side, right-hand side, do something. We'll factor out the common bits. We'll say if you've got the plus operator, that's just the same as before. If you've got star, multiply, that's the same as before. You'll notice programming language implementation involves a lot of doing the same things we've got to copy and paste. And then finally, we see why earlier I pedantically popped the right-hand side first, because minus, we actually have to get the right way round, otherwise we get weirdly incorrect answers. So multiply and minus are pretty easy. Greater than or equal, we have to think a little bit, I suggest. So if you find greater than or equal, what are we going to do? Well, I'm going to just define it the following way because it's easy. We'll perform the comparison between two things. If it succeeds, we'll put 1 on the stack. If it fails, we'll put 0 on the stack. They're not exactly Booleans, but they'll stand for it, and it'll work quite well for our situation. So we'll say if we've got the greater than or equal token, then we'll evaluate it by saying, is the left-hand side greater or equal to the right-hand side? If it is, we push 1 onto the stack, else we'll put 0 on the stack. So that's our comparisons. We could write lots more comparisons. We don't need them, thank God. So if we're lucky, that's all of the individual expressions we've got. But now we have to do the while loop itself. And I think it's probably going to be helpful for a full window here. So before, we could just go through each line in the file for line and lines. Everything worked. But now we might be executing the same line many times. So what we're going to have is what's called a program counter. And this is how real languages, it's also how CPUs execute. They know where they are in the program, and you can go back, forward, you can jump around. So I'm immediately going to say, okay, we're going to start our program counter at the beginning of the file. I can't have a for loop anymore. It's going to be a while loop, and I don't actually know how long the while loop will go around. All I know is that while the program counter has not got to the end of the file, I've still got some work to do. So I'll just say, while the program counter hasn't got to the end of the file, there's some work to do. And I have to, after every instruction, increment the program counter. So if I just execute our old program, if I'm lucky, it should still work as before. Yeah, okay, so I haven't broken the old program, but if I run the new one, P2, it goes splat. So this is where we actually implement the while loop, and this is the slightly more fiddly bit. I'm going to use the split function again, Sean. It's really the gift. I don't know who implemented that. Whoever it is, I would buy them a drink if they were here, but they're not. So yeah, thank you, whoever it was. What I'm going to do is split a line. I'm going to assume every line in the file is either variable equals expression or while something or end something. So I'm going to say, tell me what the first token of the line is. And if it's while or end, I'm going to do something else. I'll assume it's a variable assignment. So this time I'm just going to do max split equals 1. I'll take the first element, and I'm going to use Python's match syntax. So if I have a while loop, as in the start of a while, case while, I'm going to fill in the ... If it's an end statement, I'll have to do something else as well. We'll fill those ones in a minute. If it's neither of those, I'm just going to assume, and I hope the person doesn't make an error, that it's a variable assignment and I can use my old code unchanged. So I've just got to fill in those two ... Let's start with the while thing. So what we've got here, we've encountered a while loop. It's got a condition, so we need to check the condition. If it's true, we execute the body of the while loop, and if it's false, we just skip to the end of the while loop. That's effectively what we're going to do. So first of all, we've got to evaluate the expression. Luckily, isn't this lucky? We've already got an expression evaluator, so we can just say, okay, I want to ask, is the condition true? So I've got to use split again. Chances of this working out are really quite remote. So we're going to say, if the condition is true, we go through the body of the while loop. That's the nice, easy case. So we just increment the program counter, go to the body of the thing. Very good. Otherwise, if it's not true, what do we do? Well, we're going to have to search through the program to find the end of the while loop, and then go one after that. Now, I'm going to assume we don't have nested while loops for the time being to keep our life a little simple. So what we'll say is we now, in the branch I'm typing now, the condition is false. Skip the while loop. So I'm going to look forward in the program and keep looking until I find the end keyword effectively. Actually, I should get paid money for how often I'm using max split and so on and split. Yeah, I'm not sponsored, but if anyone does want to sponsor me for using that, that's a very niche sponsorship and I would question your sanity. So we just say, look forward, if it's not the end keyword, skip a line until we eventually get there. When we eventually find the end keyword, skip that as well. So we skip one extra thing. Very good. So that will deal with the case that a while loop is the condition is true or false. But we've still got to fill in one more ... is when we execute the body of the while loop, and hopefully that works. Well, actually, let's try it. This should go splat. What happens then? So it looks like our program ran up until that point. Now we've got to go back to the beginning of the while loop. So it's actually the same search more or less in reverse. So instead of looking forward for something, we go and look backwards for something. So here we'll say, go and look for the while keyword. Right. Okay, so notice we've had to type quite a lot of code in one go, and that always gives me the heebie-jeebies. So I normally like to check after every line I've changed. So we'll see. So that's actually worked. Okay, so it's told me the factorial of 5 is 120. So choose a number that's not ridiculously big, say up to like 15 or so.
Oh, let's go 13.
13. It's unlucky for some. And also, I don't know what the value of 13 factorial is because it's that very big number that looks on us. So 622 million, something like that. There's so many zeros there, I don't know. Real-time verification.
Factorial.
Exclamation mark, yeah.
Equals.
All right, I'll read it. 622,702,0800.
I'll buy that.
Very good.
Nice.
How many lines of code have we taken? They just bump the font size down. We've done it in 38 lines. I'll show 37 because that's easier on my screen. What have we done if we take a step back? We got simple mathematical expressions calculated, reverse Polish, but clearly the same more or less as normal expressions. Then we made allowed you to have lots of them. Then we introduced variables, assigning and reading, and then we introduced while loops, which also, as you very correctly pointed out, introduces conditionals as well, or branches, depending on how you look at it. That's enough to express a program that I'm not going to claim it's going to change the world. I'm afraid it's probably not going to win awards, but people do need it. Your calculator has it. And we were able to run that. So if I put the little program up again for everyone to have a look at, that little language we've implemented actually kind of looks like a programming language you might have used. It probably looks a bit more like Ruby than Python because of the while and end keywords, and no one uses reverse Polish notation in a real language. But I hope if you can squint at that difference with reverse Polish, that you can see this really is the genesis, or the core, I should say, of a real language, and we've been able to boil it down. What's that slash in the middle mean for the forward slash? Well, and there's a reason I'm typing it like this. So it still says hello Computerphile, but now we can see it says get/Laurie/index.html. So you can see a link between the thing in the browser URL